okay, with regard to some concepts that are related to the relational data model and relational database constraint. Okay, when I talk about constraint, those requirements that are needed on any database that you are going to design. Okay, and I'm not going to go through the history. Okay, you are okay with the tables, rows, Shabab? Okay, in a relation, when we talk about a relational model, which is based on a relation. Okay, relation you will see later, it is a tables. Okay, tables. When you do have a database, you will define some tables that are part of your database. And in terminology, in database terminology, it is called relation. In SQL terminology, when you go to the implementation inside your computer, it is called relation or relations, which are tables. So those relation or a table, you do have values. The values are represented by rows. You do have those rows inside your table, okay? And those rows will contain values that reflect a real word entity or relationship that are from the real world. When you do, for instance, you do have student name, student ID, the values for that student ID, the values for that student name is taken or it is extracted from the real world, okay? And it is also called the tuple, okay? When you talk about tuple, these rows, okay, the whole row here, it is called the row, and in terms of relation database terminology, it is called the tuple. Okay, this is a tuple, one line, one row is one tuple. The second row is another tuple, and so on. So we can say that student is the relation that does have many tuples, or you can say I do have a table called student with different rows. Okay, it is the same thing. It's just the terminology that is changing. Okay, guys. And the table name and column names, also they are taken from a real word. Okay, when we say this is a column name, column name SSN, it is called SSN. That means all these columns will contain the values for the SSN of each, let's say, a tuple. Home phone, the same thing. This is a column that will contain the whole values for the home phone, and you can find here also the null value. Okay. The domain, when we talk about domain D, it is the set of atomic values. When we talk about atomic, that means something that is indivisible. We cannot divide it. Okay, those values should be not divided. Okay, when you talk about age 19, GPA, I do have here address, which is one big string. It is not divided, and this is by definition of relational data model. Okay, we cannot have, as you remember, we cannot have a complex value, or we cannot have a multi-valued that can be found in any relation. The data type, when you specify data type, you are specifying the domain. Okay, when we say that, for instance, age is integer, that means the domain or the acceptable value for the age is integer. When you talk about integer, that means we do have the boundary of the integer. The integer has, I think, I remember, well, minus 32,000 value to plus 32,000. Okay, number in between. These are the value of the integer. Okay, and you can also specify, for instance, a positive integer or negative integer as well. Okay. Attribute, I've already talked about the attribute. The degree of relation, when you talk about the degree or the arity of relation, okay, that means the number of attributes, how many attributes that relation has. Okay, for instance, if I go to my relation student, I will just count the number of attributes and I will say 1, 2, 3, 4, 5, 6, 7. The arity of the student is 7. Okay, which is the degree of my relation, which is 7 attributes. In terms of representing the relation, how can you represent it? You can write down the name of the relation. Between bracket, you will write all those attributes that are part of your relation. Okay, separated by comma. Or you can write it in another way where you do specify here each attribute with its data type. Okay, for instance, name is a string, SSN is a string, home phone is a string, age, for instance, it is an integer. Okay, and this is another representation. But mostly when we do represent our relation, we don't specify the data type, we just specify the relation name, and we open the bracket, and in between the bracket we are specifying the different attributes that are part of our relation. Okay, guys. Cardinality, which is the total number of values in a domain. This is what we specified when we specify, for instance, integer. Okay, that means we say a positive integer. That means we are allowed to choose the value of the attribute among how many values, how many numbers we do have in positive integers. For instance, we do have 32,000 something. That means we can have, okay, the value for our age, because it has been defined as integer, as data type integer or int. That means the acceptable values, okay, for the age will be, for instance, from 0 to 32,000, which is a positive number. Clear, Shabab, for this one?
Yes, doctor.
Okay. Another thing, which is with regard to relation or current relation state, that means the state or the relation state, which is the value, the actual value of your database. When you say this are the value, this is the tuple, we do have values for the name. This is the name, this is SSN, home phone, address, whatever. And this one means, that means the state of our database now, right now, the state of the student relation or student table is what you are seeing here. That means actually these are the values. I do have 1, 2, 3, 4, 5 tuples, we'll have 5 rows, and these are the different values for each tuple. So this is the state of our current state or current relation state at this time. And when you give the attribute names, okay, they will indicate the roles. Also, you can interpret them. When we say the attribute, this column is called name, you know what does that means, name, you know, but it does reflect something from the real world. When we say SSN, we know what is SSN. It has been taken from the real world that is found in any company. For any employee should have an SSN, okay, and that employee is known by for instance, by that SSN, and so on. Okay, that means the name that you are going to choose, you are not going to choose something that is not understandable. Okay, as we mentioned last in our last chapter, that when we give a name to an attribute, the name should have the semantic, should have the meaning, and that meaning is taken from the real world. Okay, it's not from fiction. So anyone who will look at your attributes name, automatically he will understand that yes, this is, I can say what does it means, address, what is a home phone, what is name. Imagine that this home phone has been named as ABC, okay, and you don't know what is that ABC. Okay, you will see number, but you don't know what is that ABC. So that name should reflect, the attribute name should reflect the real world. The order of tuple, Shabab, what do you think about the order of tuple in a relation? Does it mean, does it have some order, or we can write down, for instance, if I go back to my example, so this row, the first row, I will put it on the third place, and I will move that third one into the first place. Do you think does it
على حسب
I think
primary
not.
key, doctor.
نعم.
Maybe it should be ordered depending on the primary key, like here, for example, the SSN or.
لا لا, no.
I think no, doctor. No.
It doesn't. There is no order in the tuples. Okay, the primary key doesn't have to do anything. Okay, unless, for instance, you are, when you define, for instance, when you define your database, and you specify the primary key, for instance, auto increment, it will start by 1, and then the second one will be automatically given 1 plus 1, 2, 2 plus 1, 3, and so on. They will be ordered. But when you define, like this one, for instance, when I define my database, when I populate my database, okay, I have the choice to put this tuple at the first line, or at the second, or at the last order, for instance, in my student relation. So it doesn't have, to be in a specific order. The main thing, what about the columns, Shabab?
The column, even
Yes.
column. If we switch
Can I
column
specify? Can I, for instance, go to this home phone, and I will move it to the first column, and I will move name to the third place? Is it acceptable or not?
does not matter. Yes, acceptable.
Doesn't matter. Okay, as long as I will move everything. I will not just move, for instance, the name attribute home phone. I will put it here, and the name I will put it here, and I will leave the values. When you move a column, you have to move it totally. The whole column will be moved from one place to another place. Okay, so these are the order of the tuple. Okay, it's not that important, as long as we mentioned, it corresponds to, you do have that correspondence between attributes, and the values are maintained. Okay, when we move address, I will move the whole address column to whatever the place. Okay, as long as we keep the correct value for that specific tuple, and so on. Okay, guys. Another alternative, another definition of a relation. Okay, when you specify tuple, when you talk about tuple, you can write down the attribute and the corresponding value. Okay, the attribute and its corresponding value. The null value, as you know, okay, we can have a null value in any attribute. Atomic, we said that it is the value that is not divisible. We cannot divide it, and this is, of course, this is by definition. Okay, this is by definition what is known as flat relational model. Flat relational model doesn't accept, when we are talking about relational model, the relational model by inheritance, by the definition, it doesn't accept any atomic value. And you will see later when we talk about the normalization, when we go to our chapter normalization, you will discover that the first level of normalization, which is called first normal form, okay, that will say if your attributes are atomic, that means your relation it 1NF will one normal form. That means first normal form. That means it does have the first level of goodness. Okay, you're going to see later. Inshallah, we will go back to that one when we talk about normalization chapter. As we mentioned, we talk about atomic. That means we cannot accept multi-valued, and we cannot accept composite value. Okay, for the attribute, you cannot have a composite attribute, and you cannot have multi-valued attribute. Okay, we're going to see later. If it is the case, what we will do in order to make, okay, our relation, okay, a relational model, and all the values corresponding to those attributes should accept only one value. They don't accept multi-valued. As you know, for the null value, we have already talked about null value. Unknown, exists, not available, doesn't apply. Okay, we can have assertion. That means any tuple, each tuple in the relation represent something assertion that you assert. You say that we can assert that a name represents the name of an employee or a student. A GPA represents something from the real world. Okay, we said that the GPA is something from the real world, and it is an it is, for instance, a double data type, for instance. Okay, and we know that, for instance, said that the GPA should not exceed, for instance, 4 or 5, whatever you specify as a requirement. The notation, as a notation or as advice for notation, usually the relation schema, okay, we use the uppercase to represent the relation names, and now in our case to specify the state. State, that means the actual value, the value with its actual, the relation, sorry, with the actual value. And when you specify, for instance, TUV, we are talking about the tuples. This is the notation, as we mentioned, for a student to specify the schema. Okay, we specify, for instance, the student name or student relation with its name, and between bracket all those attributes. Here we are saying that the relation schema student is made up of this attribute and this attribute and so on. Okay, Shabab? And sometimes there is another notation. Okay, we can specify, for instance, we use the dot notation to specify, to link, for instance, a relation to its database, for instance, to which it belongs. We say that an attribute, or we can specify this attribute student, sorry, this attribute name, okay, belongs to student relation. This is the notation, r dot a. That means I do have here student, we specify the relation name, dot name here. In this case, in which case it is advisable to use this type of notation, Shabab. In which case? In which scenario, for instance, it is advisable to use the dot notation? Most of the time we are going to use this notation, but in some circumstance it is good to specify that this attribute belongs to this relation by using the dot notation. Okay, this is what we are going to specify. The first, which is the student, which is the relation name, then dot, then we specify name, or we specify the corresponding attribute. Any idea, Shabab?
It's kind of like an attribute. When we want to call the name attribute of a student, then we use this dot notation.
But why we have to use, for instance, we specify the relation name dot that attribute? What it will help us? It will help us in what?
Does it do with the composite attributes?
Not, we said we don't have composite attribute.
So if you want to develop like an object-oriented
yes, but maybe, when we say, for instance, name, when I said name, okay, if I do have two relations that have the same attribute name, okay, when I say I do have attribute name, yeah, which name I am talking? Yes, which name I am talking about? I am talking about name that is part of student, or name part of employee, that relation. So in this case, if you do have, for instance, okay, attributes that have the same name and belonging to different relations, to remove any ambiguity, at that case we say it is advisable to use the dot notation to specify that. When I said here, for instance, I said name attribute, I am talking about the name that is part of the student relation, not part of the employee relation, for instance. Clear, Shabab?
يعني just to represent which relation this name belong to.
Yes, it is to specify which relation this attribute belongs to. We are talking because I do have two attributes with the same name, but they belong to different relations. In this case, I have to use that notation. Okay, guys?
Clear.
Okay. We can specify also, okay, notation. We can specify, for instance, tuple. When I specify a tuple T, I can specify that tuple by the values of its attribute. Okay, I can say, for instance, the tuple T, I do have Barbara Benson, I do have this number, this number, this number, null, and so on. Okay, that means I will specify exactly, okay, that this tuple T1, okay, this tuple T1 has this value and this value and this value, and it will be a comma separated, so we can separate those attributes. We say that these attributes are part, these are the value. Here we are talking about the value of the tuple. Okay, or you can use, for instance, the tuple, the value for the name for that tuple is this name. The value for SSN GPA age, it is this and this and this and so on. These are some notations that are part of, let's say, to specify the tuple and to specify the tuple by its values. The constraint, when you talk about constraint, these are the restrictions, okay, on the actual value. What are the restrictions for the actual value for the database state? What we accept as a value for those attributes and what we don't accept. And what is those constraints are derived from the mini word. Okay, from the real mini word, we say that, for instance, GPA is should not exceed 4, for instance. This is from the real world. This is what is found in any educational organization, for instance. And for instance, phone number, when we talk about phone number, we know that phone number is made up, for instance, of 8 numbers. Okay, we don't accept any alphanumeric or any characters. And this is based on the real world. This is how things are in the real world. So we, as we mentioned from the beginning, when you create a database, you are reflecting, okay, what is in the real world. Okay, you are including data, you are including values that is taken from the real world. So we do have those constraints, those restrictions that should be mentioned. In terms of the relations model, we do have what is known as inherent model-based constraint, or implicit constraint. Implicit constraint, it is like by definition. When we talk about a relational model, by definition, okay, we cannot have duplicate tuples in any relation. We cannot have 2 same tuples for all the values. Okay, we cannot have identical tuple or identical rows in a relation. This is not acceptable. And this is by inheritance. It is called inherent model-based constraint, which is based by definition. When you talk about the relation model, automatically what comes to your mind, we don't accept to have 2 different rows. We have 2 rows with the same values for everything. Okay, we do have another constraint which is known as a schema-based constraint. Okay, schema-based constraint will explicit constraint here, which is something that you express directly in the schema. Okay, by when you specify data definition language, using data definition language, you will specify that when you define, when you create your database, you will specify, for instance, here is an example, films have only 1 director. We cannot accept more than 1 director for any film, for instance. Okay, like we did, you remember when we did the cardinality 1-to-1 or whatever. So here we specify, when we define the schema, okay, we specify that the only value is, we can have only 1 value, for instance. We can also specify what are those values and so on. This is known as a schema-based constraint. We can have application-based constraint, or let's say it is called semantic constraint or business rule. This is can be enforced by application program. Okay, and as we said, for instance, GPA. This is what we have said previously. For instance, an employee cannot work more than 10 extra hours, for instance. Okay, when you specify 10 extra hours as a maximum number of hours for an employee per month, okay, we can write down an application inside our DBMS that will check that value each time there is an input for the extra hours for that employee. Okay, it will verify whether that extra hours, the value that has been inputted in database, exceeds the maximum number, 10 hours or la. If it exceeds, it will send, for instance, a warning message to the person who is inputting the data, saying that, for instance, this value cannot exceed 10, for instance, or whatever. Okay, this is what is known as application based, which is based on the application. You are restricting, you are making restrictions using an application. Okay, of course, a domain constraint, as we mentioned, when you specify the data type, you are creating a constraint. When we specify an integer, we know what is the actual, what is the corresponding or the acceptable values for an integer. So we do have what is known as a domain constraint, which is based on the domain or the data type you are specifying. Remember what is super key, شباب? A super key?
It's
It's
What is it?
something like a primary key, but it's unique to one entity. It's never duplicated. Or, for example, SSN can be for two entities, but for example,
Don't confuse, شباب, don't confuse between a key and super key. And this is very important concept.
yeah, but
Okay.
I mean, like super key, it's never in two entities. There is only one that is there, and never.
Okay, that means whatever, when you have a super key, it specifies the uniqueness. Okay, based on the super key, you are specify uniqueness contract, which says that no two tuples, no two distinct tuples in any state of a database can have the same value for the super key. Okay, this is what is a super key, and by default, at least, okay, every relation has at least one default super key, which is the set of all its attribute. If you, this is by default. Okay, by default, all the attribute of a relation can be considered as a super key. Why? Because we said by definition, when we do have a relational model, we cannot have two tuples having the same value for all the attribute or identical tuples. We cannot accept that. Okay, so basically, when we say, okay, those tuples, okay, now how can we make, for instance, one tuple different from another tuple based on some attribute? Those some attribute, okay, combined will form my super key. Okay, if I say, for instance, if I go back to our example, okay, we can say, for instance, okay, name and SSN is a super key. Name SSN home phone is a super key. Why? Because when I do have name SSN home phone, okay, if you go to any tuples, you cannot find identical values for name SSN and home phone together. All, for all the values. Okay, I'm talking about the all values. When you talk, this is a super key. As we said, by default, all those attributes can make my super key. Why? Because we cannot have all values for those attributes the same for every tuple. Yes?
So we can say the difference between super key and primary key. Primary key can be one value or multiple value, unique, but for super key that make the tuple unique for about between other tuples.
I am coming to the definition of the key. Now I want you to grasp the idea about what is a super key. A super key is any combination of a tuple that will make that tuple unique. Okay, as we said, if I do have a name and SSN, if I combine name SSN, we cannot have identical values for name and SSN in any two tuples. That means if you go to any tuples, you will find there is a difference between name SSN in this line and name SSN in the second line, and so on. This is what this is considered as a super key. Okay. Now, if we go to the key now, okay, let's go through the definition. As we mentioned, super key can have redundant attribute. So more useful concept, as we mentioned, it is a key. Now, look at the definition. Okay. A key is a super key. Okay. It is a super key, but with another condition, another property. Additional property is that removing any attribute from K, from the super key, from key, leaves a set of attribute K prime, for instance, that is not super key of R anymore. Okay, let's have an example. Okay, let's pick up this example. If you pick up ID, okay, let's say we are talking about employee, you have ID, name, age. Okay, it is a super key. Okay, now can this ID, name, age can be considered as a key or not based on the definition? Based on the definition, we said that the additional property to be considered as a key That means if you remove an attribute from that super key, it will not be considered as a super key anymore. Now,
No,
if I will remove an ID, okay, from this super key, and I will tell you name age is a key. Can we have name age key as a key or not?
no, we cannot, because it can be repeated.
We can have repetition. We can have two tuples having the same name and age. That's why when we remove ID, I cannot say the remaining attribute is considered as a key. Now, altogether is a super key. ID name age is a super key. But when I will say that ID name is age, okay, I will say, let's have a look now if I remove age. If I remove age, I will have only ID name. Can we
It's
consider
still key.
ID name as a key?
It's still key.
Yes.
Yes.
It is not a key. It is a super key. Why? Because, as we mentioned, a key is first, it is a super key. And we do have this additional property, which is, the additional property is, which is in reality minimal super key. What is minimal super key? To be, at the beginning you do have a super key, okay? And you will ask yourself whether this super key is minimal or la. What is meant by minimal? You will ask yourself, if I remove one attribute from super key, does the remaining still super key or la? Okay, as we gave here an example. When you do have ID, name and age, okay, it is a super key. Now, if I remove this age, do I still have super key or not, Shabab?
Yeah, we still
Yes,
have.
because you
We
still have the
super
ID.
key. That means it is not a key. Now, if I remove name and I will leave ID and age, do we still have a super key or not?
No, we'll have key.
ID and age, guys. ID and age. This is the remaining.
A super key still.
It is a super key. Now, if I remove name and age at the same time, I will have only ID.
Yeah, this is key. Not super
This
key.
is a key. Why? Because it is a minimal. Minimal, that means we cannot remove anything. Okay, we cannot remove any other attribute. If I cannot remove any other attribute, and the remaining attributes are the necessary attribute to be super key, it is a key. That's why we said it is minimal. Okay, always to choose your key. Okay, you start by super key, for instance, and try to remove the attribute. Say, if I remove this attribute, do I still have the super key or not? Yes. That means this attribute is not necessarily. Okay, I don't need name and age to differentiate or to have that uniqueness between one tuple and another tuple. I don't need that. Okay, the only thing that I need to make different one tuple different from the other one is based on the ID. Okay, Shabab? That's why we said that the super key is a minimal. Okay, sorry, the key is a minimal. So when you specify a key for your relation schema, okay, that key should gives you a uniqueness. And this is what I have seen in your project. In some of you, the project, some of your Shabab have chosen name in an entity in the ER diagram, okay? In the entity, they choose the name as a key, which is not real, which is not correct. It is not correct to have a name as a key. How can you make two tuples different by name? The name is not unique. We can have the same name for all the tuples, for instance. It cannot be a unique. It cannot be considered as a key. So you have to be careful when you pick up an attribute and you say this attribute will a combination of attributes is a key. That means the combination should be unique. We cannot have two tuples having identical values for that key. Okay, and here super key, it is okay. Super key, I do have ID, name, age, whatever. But I will ask myself, is that super key? If to be a key, I should have minimum attribute. What is meant by minimum attribute? You ask yourself, can I remove this attribute and I will still have a super key? Can I remove age and ID name will be considered as unique, yes, I can have it. If I remove name as well, can I have ID and age, for instance, combined together to give me a uniqueness? Yes, but it is super key. Now, can I remove name and age and I will leave only ID? ID is minimum. It is only one attribute. This is the minimum. That means this is my key. Okay. And this is what is known as when you do, sometimes you do have candidate key. What is meant by candidate key? Sometimes you do have more than one attribute that you can use it as a key to give you that uniqueness. If you remember with car, when we said car, you do have number plate and you do have a chassis number. Okay, the number plate, we cannot have two cars having the same number plate. We cannot have two cars having the same chassis number. That means chassis number can be a key. A number plate can also be a key. These are called a candidate key. In my database, I will choose number plate as a key, as a primary key. Okay, that will be designated from those candidates. The candidate like Murashahin. Okay, you have Murashahin and you choose only one as a president. I choose this one, another guy will choose another one. The same thing. Candidate key you will have in front of you. In some circumstances, you can have more than one attribute that can be unique, that can be used as a primary key, and you pick up one of them, and this will be your primary key. Okay. What else? And this is the way how we can specify, okay, the schema for a relation. You will specify the name of a relation, and you will put, okay, all the attributes that are part of your relation. Okay, and you underline those attributes, that attribute that is a primary key. Okay, to specify that SSN is a primary key, D number is a primary key, the department number and location together are my primary key in this relation, and so on. Okay, and this is the way how we have seen how we can represent a relation by its different attributes, to say that these are the attributes. State, as we mentioned, the state for the relation is the actual value. Okay, for instance, this is the state for my company relation database. These are the values for the employee relation. These are the values for department location. I do have these values, and so on. So these are the actual state. This is what we have as in my database. Okay, and now
it's the same as the snapshot, right?
Yes, it is a snapshot. Yes, a snapshot. So, sometimes a snapshot is related to the user view. For instance, as an administrator, I will look at that database. I will look only CS340 student. It is a snapshot, but I am not looking at the whole database. But when we say the state, the whole data that is actually stored in my database. Okay, guys?
Okay.
Okay. Invalid state, that means something that doesn't follow the integrity constraint. Okay. Valid state, that means you do have all those constraints, specific integrity constraints are validated, are verified. Entity integrity constraint, that means no primary key value can be null. We don't accept when you choose a primary key, never and never and never put a null value for the primary key. Okay. Referential integrity key, that means you specify the relation between two relations by using the foreign key. Okay, if I want to look at a relation, what is the relation between student and courses, for instance, I will have some links between them. In this manner, I will use a foreign key. Okay, a foreign key can be used to just to specify, like here, for instance, I do have here customer ID. Okay, that will go the same in this relation, and I will just mention the customer ID here, the same one. Okay, because we are not having the same data within the, we gathered all the data, all the attribute with one big relation. So the definition or the attribute are found in different relation. So we need to have some link, and you specify, you go, for instance, from one, you go to the corresponding customer ID in another relation, which gives you, for instance, the amount and whatever this customer ID has bought, for instance, from Google. And how we can specify them in relation model? Okay, you do have that line from one relation that will goes to another attribute. Okay, and the referenced attribute in another relation has an arrow. Okay, that means this one doesn't have an arrow. That means this DNO is a foreign key that will refer to which attribute it refers to the number. And always, Shabab, that reference, it will always reference to a primary key in the other relation. You will never have a foreign key referencing to another attribute which is not a primary key, will have part of the primary key. Okay, don't do that mistake. When you are asked to create a foreign key, you pick up a key, an attribute from one relation, and that attribute from employee will have a reference to department relation and to which attribute to the number. This D number in department location is referencing to another attribute which is primary key D number in the department. If I go, for instance, PNO, project number is a foreign key that is referring to a project number, which is here primary key in another relation. ESSN, this foreign key, this is a primary key combined with piano, but it is also a foreign key that is referring or referencing to an SSN in another relation, which is SSN as a primary key, and so on. So this is the way how you are going to specify a foreign key in another relation, how you are going to create, to make relation between relationship between one relation and another relation.
Doctor?
Clear, Shabab? Now.
Shouldn't the foreign key be exactly the same naming as the primary key?
No, for the naming, not necessarily. And usually we don't choose the same name because we will have an ambiguity. Okay? As long as it refers to the same thing. Okay? I called it D number, and in another relation it is DNO. Okay? They are the same, but it should not be the same name. Because when I tell you, for instance, D number, you will ask yourself, which D number? Is it D number in department relation or D number in department location, for instance? If they do have the same name. But when you do have names different, so you can automatically say, I'm talking about this attribute in this relation, in order just to remove an ambiguity. We can have that. I'm not saying we cannot have it, but as a guideline, it is better to have different name to remove any ambiguity between the attributes names in different relations. Okay, Shabab?
Clear, yes. More of a convention.
Okay, so we'll stop here, inshallah. We'll continue.